Hi, this is Srijit. Uh, I created this channel some months back with the thought of catering to basic data science. That is, to explore each topic and concept in data science from a core mathematical perspective. To explain each topic from a mathematical standpoint, incorporating mathematical understanding in each of the topics that are there in data science. The other reason or motivation behind this was to create a platform for community discussions about AGI, artificial general intelligence, and to encourage talks about more and more talks and conversations about brain accurate computational building, computational model building. Um, in that space, there has been a lot of developments recently, mostly using text as data that categorizes these developments mostly in the areas of natural language processing. There has been a lot of developments in the generative AI space, and we currently have a lot of large language models prevailing in this in these areas. Most widely adopted has been Chat GPT, which were launched some months back, and that kicked off very focused race or a streak of gradual developments, consistent developments in conversationally capable large language models. Currently, the betterment has reached to such a stage that we have open source large language models. The efforts had begun um, some months back already, 5 to 6 months back, with the advent of MPT, with the advent of Llama, Alpaca, Vicuna, and more such models, OPT, and more such models. The recent model that has been launched some 2 days back has been the LLAMA-2 model by Meta, with association with, associated with Microsoft. So this Llama-2 model is currently at par with ChatGPT. The conversational capabilities are matching and very much, and are giving quite a competition to ChatGPT. If the more positive thing is that it's open source. So for a community that is developing these kinds of chatbot systems, it's a very hopeful situation. It's a win-win situation. So today's my agenda or the video is regarding adopting this Llama-2 model and creating the skeleton of a chatbot system purely on Google Colab, just using Google Colab GPU. There has been a lot of community adoption already using this of the Llama-2 model, but the simplest explanation or simplest way to create this just on Colab uh, and reach to a stage such that given any user query, the pipeline provides you with a response, provides you with a relevant reply that is still not up on YouTube or anywhere. So this will be a contribution towards the community, and it will be about how to use Llama-2 uh, to create a skeleton of or a chatbot skeleton just using Colab GPU in the simplest possible way. So let's get started. I will share the screen quickly. Okay. So first, I'll show you the official announcement from Meta, the official site of this llama from the meta.com website. And you can see there are lots of versions of llama. There's a smallest version of 7 billion parameters. Then there is a version of 13 billion parameters, and then there's the largest version so far of 70 billion parameters. What are these parameters actually in a model? They are nothing but the factors that decide the model behavior. Like for example, just a quick example would be, let's say you want your model to stick to a context, right? You have given a context and you want the model to give you answers specifically with respect to that context and not create up a lot of sentences, not create up a lot of text. So for that kind of a behavior, you have a factor or a parameter known as temperature. So the temperature you set is low, then it would stick to the context and not create up a lot of sentences on its own. The responses that it will generate will not be random, but will be very, very focused to the context and sticking to the context. Whereas if it is large, high value, the temperature value is high, then it will generate more sentences on its own. So that is parameters. So in the same way, there are 7 billion parameters in this model, in this version. There are 13 billion parameters in the later version, and the one so far that has the highest number of parameters, combining any closed source or open source, whatever it is, that's 70 billion parameters model. You can read about all these parameters. What are these parameters from two websites? I'll mention two good websites as references to read about LLM parameters. This one is one from where you can actually understand the definition or theory about what are LLM parameters. You can see from here. And just one example is given, the example that we already discussed, that is LLM temperature. More such examples you can find on this website from txt.cohere.com. Here you'll see some more model parameters. But at the end of the day, these are all such factors that define the behavior of your model. We'll be using the smallest model, that is 7 billion parameters. Simply since we are using the Colab GPU, which has I think 15 GB, if I'm not wrong. We'll check that anyway. So that's about it. You can see the model performances, how the model is compared to all the other models. The ones that we discussed, MPT, Falcon, you can see it here. They have been good initiatives, good efforts in developing, providing open source solutions of creating chatbot or chat systems. But with the advent of Llama, it seems it outnumbers them in a lot of performances. So this one is provided by Meta itself. These performance comparisons is provided by Meta. I'll show you, just give me one sec. So I'll show you one more platform where you can where you can get a performance comparison of all these models, and which is, not from any LLM builder, like Meta has built Llama. But this one is called Hugging Face, which facilitates wide adoption of these models. So getting a validation from here seems more trustworthy if you see it in that way, because it compares all the models um, uh, from a neutral viewpoint, and then gives you a performance comparison. So this Open LLM leaderboard is a space from where you can see all these comparisons. So I have been following the developments very closely for the last uh, 1 month about open source models, and even before that for closed source models, and created a chatbot using the previously, I mean, before the open source, there was obviously the option of creating chatbot using the OpenAI API. So create a chatbot using that. And these developments in the open source space has been quite interesting. So this one that you see here, it's currently, I cannot see actually. Falcon, Falcon Instruct. Just 2 to 3 days back, it was topping. It was winning in all the model performances. But with the advent of Llama, you can see Llama 30B Instruct uh, is currently showing the best performance. I'll show you on what perspectives these performances have been measured. So very interesting thing that is going on. If you just follow or track this space, you'll see at each, if not seconds, right, at each hour or each day, uh, there is going on, there is always a change in the order. There is always a change in the rank. Previously, I saw this one 70B to be at the top. Today, I am seeing upstage this one, Llama 30B Instruct to be to be on rank 1. So you can see this one is the average score. There is ARC, HelloSwag, MMLU, and Truthful QA. These are all data sets on which these model performances are being calibrated. And about these data sets, you can read from here in the about section. So these are all the data sets. You can also open those data sets and see what are those data sets and what are they about. The descriptions are already here. Okay, so that's about the more of a context of what is the model that we are going to build to create a initial build up about before getting into coding. So start with that. There is these models have been I mean provided. What the model that we will be taking today is the Llama-2. So this model you can get from here itself. You can download the model, but just directly you cannot download it. You have to request for access. I'll show you from where you can actually download this. Yeah, from here. So you can download the model, get started, and you have to request for the access. And then once your access is validated, you are provided the access, your request is accepted, then you will get access to the model and you can download the model. So this particular user, the bloke on Hugging Face, has gotten access. And what good thing that is done here is he has changed all these models to transformer friendly models, and such that these models can be used in a lot of implementations, right? So you can see use in transformers. There is a way to use these models in transformers, and there are other ways in which you can use these models. So this Llama 2, here you can see 13B model, but we'll be using the 7B model, 7 billion parameters model. You can use any of these two transformations, that is GPTQ, as well as here you can see GGML. So any of these two transformations you can use. Today we'll be using this one, the GPTQ model. The GPTQ model, mostly because it is quantized. I'll get to the explanation of what is quantization and why we're using this model. But let's get started for now. So you can see the way of coding from here itself. This is the whole code that we have to just use. It's provided from here. And if you just use this 13B chat model, you'll not be able to run this on Google Colab. So we'll be using the 7B chat model, but all the other things remaining same. So at each step, will be going through the code and explaining what are each things for. Let's open a simple Colab notebook. Right. So we'll be creating a new Colab notebook and we'll be setting the runtime to GPU. Let's give it some time to get created. Let me change the name. We are using this is nothing but a Llama 2B, Llama 2 7B chat. Let's use these things from here. So first thing is I'll take transformers. Transformers is provided as a Python library. If you do not have transformers, then you can install transformers. Let's see. So this is a new Colab notebook. So obviously it will not be installed there. So maybe I have to install, but let's see. So anyway, I have to install, I think. So I'll first install this. Pip install transformers. The other library that I need is pip install auto. I forgot how it is written. There is an underscore in between. So I'll take this one and I will install this. So these two libraries are installed. Next thing that we'll do is we'll import whatever is required from these two libraries. So what we are importing is an auto tokenizer from transformers. We're importing pipeline and logging. So for model building, what we'll require is mostly auto tokenizer, which will be used to tokenize uh, the text. So basically we'll create a tokenizer using this model, particularly the Llama-2 7B chat model. And what it will do is, why we need a tokenizer is to cut short or make the whole text that will be in the process, will be taken in the process into bits and pieces. So each long text will be shortened to small tokens. That will be done by the tokenizer. Next, you have pipeline. In that, using that pipeline will create a whole workflow. Will be creating a structure that will help us to generate text. So we'll be creating a text generation pipeline basically. And then from auto GPTQ, we'll actually take auto GPTQ for causal LLM, and then base quantize config. Where we'll use them, we'll see. Let's take this model path. So instead of taking the 13B model, we'll be taking the 7B chat model. Oh, I forgot a crucial thing that we should have done at the very beginning, that is making the runtime as runtime type as GPU. So maybe I have to run all these things again. It will restart the runtime. Okay. And we'll keep this one open just to see what are the how much is the computation requiring at each stage. So I'll run this once more since it is a new runtime. This will take some time in downloading. Sorry, installing. So once it will be downloaded, then we can import whatever is required from transformers and from auto GPTQ. While it is downloading, we'll get the signal from here once it is done. So it is currently gray, it will turn to yellow when it is done. So we'll see what are the next steps here. So use Triton. That is a parameter that will be requiring for the model. We'll see that when we take the model, when we download the LLAMA-2 7B model, 7B chat model. Tokenizer, here we are creating a tokenizer using the model name. So the model name is this one. The model name or path is this one. And we are creating a tokenizer using the same model. So what it will do is it will tokenize the text in such a way such that it becomes compatible with the LLM that we are using. Because we have created a tokenizer, giving this one as the model, So to create a tokenizer that will be compatible with the LLM that I am using. So it will tokenize the text or make pieces of text in such a way, so let's say I have one word, it will break the word into tokens in such ways that this tokenization is compatible with the LLM that I'll be building later. It's still not done here. It will take some more time. Let's give it that time. You see the change in RAM usage, right? When we are running everything, suddenly there is a drop, suddenly there is a high. And when we'll be downloading the model, we'll be seeing a very very high usage of RAM here. It will not be, I mean, this system RAM, that is the CPU RAM, will not be enough. You'll see a spike in the GPU RAM as well. And that's why we need a GPU to run this model. But the good thing is, for a 7V model, the Colab GPU, that is 15 GB RAM, is enough. But to run a 40 or 70 billion parameter model, you need a better GPU, GPU that has even more RAM. Let's run this one. And then I will take the model names and the model base name. So the model name is a 7B chat. It's a LLAMA-2 7B chat model. So you can, I mean, we saw in the Meta website that it's LLAMA-2, and the parameters thing we understood that it can be 7B, it can be 13B, and it can be 70B as per LLAMA-2. Well, now, what is this chat? Right? So by default, these LLMs are generative models. They can generate text. Once you give them some starting point of a text, they can create more text, more text, more text. But just a LLM is not capable of providing you responses that are meaningful for you. When you are asking a question, the text that it would generate, there is not 100% assurance that it will be meaningful. It will be exactly the kind of response that you're wanting. It may be something else as well. Irrelevant generation. So on top of these LLMs, LLMs that have generative capability, we have uh, uh, instruction fine tuning. We do instruction fine tuning, and after this instruction fine tuning, they become some sort of capable to give you right responses, to give you better responses. And those are instruct models, not just generative LLMs. They are known as instruct. So if you see an instruct model like Falcon Instruct we are talking about, you'll see written Falcon 7B instruct. Right? So it there is more to just a raw LLM. It has been fine-tuned using instructions. So those kinds of models are capable of obeying instructions from the users very well. If you give it an instruction, it will be able to generate based on that instruction. But there is again, it is not exactly a chat model. So for chat, it needs to understand the text and then needs to give you responses. And what is needed more is that it needs to look at a lot of chat responses from before and then get trained on those chat responses. There needs to be a consistent um, effort of giving feedback to the model. So once the model gives you a, you ask a question and the model gives you a response, gives you a response basically. You will give the model a feedback, how good the response has been. You'll rate the model, and there is a collective um, group of people involved in this process of giving feedback to the model. So that way the model learns and learns and becomes better. That is known as reinforcement learning, and this process is known as RLHF, reinforcement learning human feedback. So that has been very well done in ChatGPT, and that's why it's a very good chat model. It's able to complete, give you, complete a chat thread very well. So chat GPT is actually not, it's a well fine-tuned, instruction fine-tuned, and RLHF incorporated GPT 3.5 model. If you go to their site, you'll see this whole process in an elaborate way. They have mentioned what are things done. and that's why it works so well. So this one that we are taking, chat, it's written here chat. So this is also a model that in which RLHF has been incorporated. So that's why it will be also very much capable of giving you right chat responses. It would not be just text generation, but also will provide you with uh, relevant responses that you are wanting for your user query. So that's the kind of models. So on one side you have the with respect to the parameters, 7B, 13B, if you have 30B in some models, and on the other side, on the basis of fine tuning, there are just LLMs, generative LLMs. Then you have instruct model, better, I mean, a step ahead from LLMs, and then you have these chat models. So I've taken a chat model. Now we'll see what we'll do with this. We'll take this one, use Triton. This is a parameter in the, this is a parameter that we'll use while downloading this model. For now, we'll just create this variable and assign the value false to it. Next, we'll use this tokenizer. Let's take one thing at a time. First, we'll create this tokenizer. It comes from autotokenizer.pretrained, and the model name is given here, and we'll use fast. So there is a tokenizer called LLM fast tokenizer in Hugging Face. So we are using that sort of a capability here as well. So we are giving use fast as true. Let's run this. It will not take a lot of time, just a few downloads and it's done. Then we'll take the model. We'll download the LLM model. And from quantized. So the tokenizer, what we had used is auto tokenizer dot from pre-trained. In here, we'll be using, these are all provided by Hugging Face transformers. These are, functions, dot from pre-trained, dot from quantized. These are all provided by Hugging Face transformers. The transformations library is itself provided by Hugging Face. So these functions from pre-trained or from quantized, these kinds of functions are also part of the transformers library. So this auto tokenizer itself comes from transformers. So it's a part of the transformers library. Now you have here from quantized. So here we have taken from pre-trained because we are taking a pre-trained model. That is, this one is a pre-trained model. Here we are doing from quantized. We could have also taken from pre-trained, just like here. And in many models, we actually do that. But in this case, we are taking from quantized because this is a large model and we want to quantize this model into bits and pieces. So that will help you what? In downloading the model in not just one go, but in several goes, in several small parts. And that will help you offload from the RAM sometimes, onload from on the RAM sometimes, such that there is not a lot of memory required, but still will require some amount of memory, but not as compared to if we do it in, if we download the whole model in one go. So you can see about quantization again from quantization from some blogs. You can read about auto GPTQ that we are using currently. From here, I have read about this previously, so you can see that it's showing red kind of a color. And quantization, you can read about quantization of LLMs. in theory you can read about. In AutoGPT, that like in that library also you can read, in that site also you can read about this. I'll show you. So from here you can read about from weights and biases. This is a site from called WANB, weights and biases. You can read from here as well. And this site also that I had opened before. Oh, this one also will give you a fairly good overview of what is quantization and everything. Will quantization affect my performance of the model? So you can read about quantization from any of these places. On a overall summary, quantization is just I am taking the model not just in one go, but downloading it on breaking it into pieces, and these are known as shards, SHARDS, and that helps in effective use of the memory and the RAM. So we run this. You see here we have mostly here I think we have used the previous one, use Triton. We're using, yes, here we're using use Triton as the value that we keep here, that is false, and the device that we are using is CUDA. You have to give trust remote code because this is coming from a remote source code. This model is located at a remote source code. So you have to give this one trust remote code equals to true. But even if you don't give, it will ask for permissions during executing the code. Then also you can give yes, Y, and it will run. For now, I'm giving trust remote code as true, so it will not ask for any more permissions. Run this, it will take some time, and you see the impact here. There is no such change currently, but you will very soon see a spike in the GPU RAM. It will not be very much. I think it will go to 6 GB based on the last time I ran it. Yeah. So your GPU RAM has started spiking. It is currently 1.4 GB of the RAM has been used. If we actually use larger models, currently 3.8 GB of the RAM is used, and it's done. It has not even gone to 6 GB. Oh, sorry, maybe my mistake. We had seen maybe 6 GB here and here. Okay, so it is going. So anyway, within 15 GB, 15 GB of RAM that Colab provides will be done with downloading the model, and then you can use the model. But if you use more, larger versions of this model that has for 70 billion parameters or even 13 billion parameters, you'll see this much GPU will be not, this much GPU RAM will not be enough, and your session will crash. So for running those models, you need actually an infrastructure, maybe some instance, GPU instance on GCP or AWS. But this one is for a 7B model. I had tried this previously for Falcon 7B as well, and it worked pretty well. So for any such 7B model, my assumption is it should work pretty good. Just a GPU that Colab provides on a free tier is looks to be good enough to go. So now I have taken the model. Now I'll use this model. Before using this model, I'll just create up the prompt. You can create your prompt in your way also. For now, I'll just use the prompt that is prescribed. Let's say, tell me about AI. Let me change the sentence a little bit, or the question a little bit. Let's say I ask, what is gravitation? And this is the kind of prompt that instruction that I have given. I'm not changing any of these instructions. You can change also. You can fine tune. I mean, experiment with different instructions. You are helpful, respectful, and honest assistant. Always answer as helpfully as possible while being safe. Your answer should not include any harmful, unethical, racist, sexist, toxic, dangerous, or illegal content. Please ensure that your responses are socially unbiased and positive in nature, and many such things. So this is an overall general good instruction that is given to the chat model. To read about what are the possible, I mean, good prompts, good instructions, you can also see this course from on prompt engineering, recently launched by, I think, deeplearning.ai. It's available for free. I'm not sure if it's still free, but I had done it a month back, so at that time it was free, and you will get to learn some new hacks which will be useful for giving or prompting to your chat system. So which one was ours? Here. So we have given this kind of a prompt, and we are asking the question, what is gravitation? Let's run this. It will do nothing. It will just take the prompt, and then when we pass this prompt through our model, then we'll get the response. So we'll be using this input IDs and everything, and I think this should be enough to give you the response. I'll show you using pipeline as well, since we have already imported pipeline. So in both the ways, we can get responses. So if I run this here inside prompt template, we are passing all these things, and this prompt, this question was actually a part of this prompt template. So this question I'm placing here. Then after that, I'm getting, then after that, at the end, I'm giving this print generate. So at the end of this whole prompt, we'll be able to get the generated response. So we're using model.generate function. The model is simply the model that we have taken. And then there are some parameters that we need to give, input IDs. Input IDs is something that we are getting from using the tokenizer that we had done initially. And see, in that tokenizer, we are giving that prompt template. So this prompt template, whatever is here, is being tokenized or broken down into smaller pieces. And we got a response. See, the temperature is actually a parameter that we have discussed initially. So I've given a 0.7 temperature, which is pretty good to give. So it will provide you with a little generative response, but also not deviating a lot from the context. Here we have not given any context anyway. So the only prompt that is there is what is gravitation. So it will provide you with the answer. So the answer you see, this is the question that you have given, what is gravitation? It is the answer that is provided you. Gravitation is the force that attracts two objects and everything. If you change the question here, you get a different response. So that's how you have created a chatbot. I'll further show you how to, this is just a skeleton of a chatbot. You can use this mechanism as a constituent or a component of your whole large scale system to create a chatbot. Here I will show you how to use a pipeline to create the chatbot. So this pipeline is again from Hugging Face. we had downloaded this previously. I'll show you again where we had imported this. It imported this from here, you see, transformers. So transformers was something that was provided by Hugging Face. So pipeline is we are getting from Hugging Face. Now, the kind of task that we are doing is text generation. Here, there can be a lot of tasks that you can provide here. Many such tasks. I will show you the official page of, from the website of Hugging Face itself. So you can see in models, these are all the tasks that you can provide. So what kind of task you want to do, we'll just provide that kind of task here. See, we are doing a text generation. So this is the task that we're doing. You can do text to text generation as well. So this is mostly, say, sequence to sequence generation, like translation, language translation. So you're providing a text in some language, and you're again getting a text in, you're again getting some other text in a, the equivalent of this text in a different language. That's text to text generation. You can do table question answering, whatever, text classification. There are many such tasks. Currently, we are using it for generative purpose. So we'll be using text generation as the task. See, the temperature we have given here is 0.7, just like what we have given here, the same kind of temperature. Top P we have given as 0.95. So top P and about all these, what is this, parameters you can read from, not this one, this reference that we are referring to earlier. So top P, top K, these are all given here, and you can read about all these parameters that you can configure to make your model behavior, that is to experiment with your model behavior. So where, this is my notebook. Let's create this pipeline. So what is this pipeline basically? Pipeline is basically, we are creating a framework that will use later to do this, to get chat responses. So once we create this, the framework that we are creating is a text generation framework with all these parameters given. Now, when we use this, when we pass the prompt through it, then it will be able to provide you with response. Currently, just the framework is created. Now I will use this framework where we GGML, where we use GPT, yes, this one. Now we'll use this framework to create the response. So see, in here I am passing this prompt template basically, in which that prompt is contained. Let me print this, and then you'll get the response to your prompt. This might take some time. It didn't take a lot of time here because the prompt is very small that we have given. You can see it has given the answer. Okay. In most of the cases, see, the response here and the response here will be different because it's obviously a generative AI, generative language model. So it will generate based on it's not like it already has the answers and it's just matching your question to the answer, but it's generating the answer. So the generation will be different each time, just like we give out different responses even when the same question is asked at different times. We do not match anything and give it out from the database. So in the same way, it is also generating its own responses. So I'll quickly show you, if I actually give a context, then also it will work or not. And that will be the basis based on which you can create your custom chatbot also. Let's say I give a context. Let's say Neuralink. Okay. Is creating brain chips. I'm not sure whether it will be trained on this kind of a, I mean, information or not. But it's not a very new information, so it should be able to understand the context. So Neuralink is a brain chip. Okay, so this is the context that I'm giving. After that, I'll ask the question. So this is the context. Neuralink is creating brain chips, and it is owned by Elon Musk, and there's multiple lines. So I'll give these kinds of quotes. Owned by Elon Musk. Anything else? So it is. Yeah, that's all. Let's say this is the context that I'm providing, and the prompt that I'm giving is, let's say, prompt is, tell me about Neuralink. Tell me about Neuralink. Okay. So again, this will be a text, so I'll keep it within quotes. Inside the prompt template, it will take the template. I want it to stick to the context, so I will change the instruction a little. The instruction that I will give it is, answer the following question using the context given below. And here I will provide the context first or the question first. Context given below. So let me provide the context first. So context, and I have context in that variable context. I'll place it here, and then I'll ask a question. Let me give a little more space here just to make it cleaner. So question I give here, and it is in the prompt variable. So it is already passed, so I do not need this again here. So I'll remove this, and then it will generate. So looks good. Let's just quickly cross check once more. I will give a space. So tell me about Neuralink. Tell me. Okay, let's give a just a what is that? Full stop here. Let's run this. Okay. Let's get the answer. So it is generating the answer. And the temperature we have is 0.7. We'll change the temperature after this, and we'll see if there is an impact in the output that I'm getting. Yeah. So we got the answer. Neuralink is a neurotechnology company founded by Elon Musk. So it has understood the context and has given me the response. It's given me a pretty well response. Overall, Neuralink is a pioneering company in the field of BMI technology, that is brain machine interface, if I'm not wrong. Brain machine interface technology, as it and its work has potential to revolutionize and everything it has given. Let me give a very low temperature, let's say 0. So 0 is the lowest possible temperature. That is, I want it to exactly give me, stick to the context and not generate a lot of things by itself. Let's see what is the change in the model behavior and what is the kind of response we get. So we get more or less the same kind of response, but looks a little shorter than the last time. but yes, it has generated, because the context itself was not much. Maybe if we give a even bigger context and we ask then a question, then it will be able to, then it will give answers, because it will be able to get a lot of information within the context itself. Currently, it's just one sentence that has Neuralink mentioned in it, in the context. So it has to generate its own sentences to tell you about Neuralink. So that's what it has done. Yeah, and that's the way you can create your own chatbot, just on Google Colab. So maybe on top of this, um, if you want to show a demo or anything, if you want to create it just for a very small scale purpose, you can just use the Google Colab, or you can build anything little more better system with some UI on top of this capabilities that Google Colab provides. That's your LLAMA-2 7B chatbot. We'll not call it just a chat system, and will be it was something that was very interesting to find out that when it started initially, it needed a lot of GPU and everything. But currently, the open source models, even be it the lightweight ones or the very low number of parameters ones, but still we can use them on just Colab GPU. And that's the capability that we showed in this video. Many interesting things coming up in this space, LLM space. Stay tuned. Uh, let's see the advancements together, and let's enjoy the pace at which this LLM landscape is gradually becoming more and more interesting. So that's it for today. We'll try to come up again with another interesting exercise like this. And that's all. Okay.